This video is about solving the equation using zero product property, which is also called ZPP, and factoring and solving a quadratic formula with a value of 1. So before we get to our new information, we want to review factoring. So we want to factor the following. Remember, when we're factoring, we want to multiply to the number that's by itself and add to the number next to x. So number 1, we want two numbers that multiply to 14 and add to -9. Because we're multiplying to a positive and adding to a negative, we need two negative numbers. So two numbers that multiply to 14 are 2 and 7. We can make them both negative to add to -9. So in our parenthesis then, we would have x minus 2 and x minus 7. In number 2, we have x squared plus 8x plus 15. So we want two numbers that multiply to 15 and add to 8. So we're multiplying to a positive and adding to a positive, so both numbers are going to be positive. Two numbers that multiply to 15 are 5 and 3. So we would have x plus 5 and x plus 3. In number 3, we have x squared plus 4x minus 32. So we want two numbers that multiply to -32 and add to +4. Because we're multiplying to a negative number, we want one of each sign. So we want a negative and a positive. If we're adding to 4, the bigger number is going to be positive. So we have 8 and -4. So x plus 8 and x minus 4. In number 4, we have x squared minus 49. So in this case, there is no x term. So we are adding to 0 and we're multiplying to -49. If we want to add to 0, that means we need the same number that's going to be positive and negative. So if I look at 49, I know it's a perfect square. So the square root of 49 is 7. So we could use +7 and -7. So we have x plus 7 and x minus 7. Number 5, we have x squared minus 4x plus 4. So we want two numbers that multiply to +4 and add to -4. So we want two negative numbers again. So two numbers that multiply to 4 are 2 and 2. To get to -4, they both need to be negative. So we have x minus 2 times x minus 2. If it's ever the same factor, you can always write it as x minus 2 squared. In number 6, we want two numbers that multiply to 35 and add to 2. Well, there's no numbers that multiply to 35 while adding to 2, so this is prime. Before we get to zero product property, we're going to look at the graph of an equation. So using our graphing calculator, we're going to type in the equation x minus 3 parenthesis x plus 4, and in y2 we're going to put 0. We're going to hit zoom 6 to reset our window in case something happened to it. We can see our picture. So we can't see the vertex, so I'm going to go to window. I'm going to change my y max down to -15, and then I can sketch a graph on my picture. So here is my equation. We have our parabola. So the vertex here is a min. To find that on our calculator, we're going to hit second, trace. We want option 3, which is minimum. We want that blinking cursor to be to the left of the vertex, and then we want it to be to the right of the vertex, and then hit enter a third time. So that gives us our minimum is at -0.50, comma, -12.25. So when we're looking for solutions, remember that solutions are also called your x-intercepts. So what do our solutions represent? They represent the x-intercepts, or the zeros, of the graph. So to find those, we're going to do second, trace 5 for intersection. We're going to move to our first point, enter 3 times, and that's going to be -40. And we're going to do it again for our second point, second trace 5, move to the right, enter 3 times, and that's going to be 3, 0. So our solutions are negative 4, 0, and 3, 0. So the zeros represent the x-intercepts or the zeros of the graph. We can also call them our x-intercepts or our zeros. When you look at the equation compared to the zeros, see our equation is x minus 3, it switches signs, x plus 4, it switches signs. So what do we notice? The solutions switch their sign from the equation. So that's what happens in zero product property. When we have an equation, what basically is happening is each part of the equation is being set equal to 0. So we have x minus 5 equals 0 and x plus 4 equals 0, and then we can switch our signs. Because if I add 5 to both sides, x would equal 5. Because we cancel it out on the one side, we moved it to the other. So if I subtract 4, it cancels out, x equals negative 4. So when we're doing zero product property, each part of our equation that has an x is going to get set equal to 0. So in number 2, we have x equals 0, that's one solution. And we have x plus 3 equals 0. So we can subtract 3 from both sides and x equals negative 3. Now, if you notice that it's just x and a number and that it switches signs, you don't need to show this middle step, but I'm going to keep showing it just so it is a reminder of what's happening. In number 3, we have 2 sets of parentheses, so each of those gets set equal to 0. X minus 7 equals 0. 2x minus 4 equals 0. So in the first one, we're going to add 7 to both sides. X equals 7. The second one's a little more work. We need to add 4 to both sides. So 2x is equal to 4 because we're going to add 4 to both sides. And then we have to divide by 2, so x equals 2. In number 4, we have 3 terms. So we have x equals 0, we have x minus 9 equals 0, and x minus 1 equals 0. So for x minus 9 equals 0, we're going to add 9 to both sides, so x equals 9. And we're going to add 1 to both sides, so x equals 1. So in this case, it's going to have 3 solutions. In number 5, this 4 doesn't have an x with it, so we're going to ignore that. We're not going to use it in zero product property. So we just have 2x minus 6 equals 0 and 1/2 x minus 9 equals 0. So in the first parenthesis, we would add 6 to both sides. 2x equals 6, divide by 2, and x equals 3. Here we would add 9 to both sides, so 1/2 x is equal to 9. We can multiply by the reciprocal of 2 over 1, so x is 18. So in this equation, we only had 2 x's, so we get 2 solutions. In number 4, we have 2x equals 0, negative 5x plus 10 equals 0, and x plus 1 equals 0. So if I divide by 2, 0 divided by anything is still 0 for one solution. We're going to subtract 10 from both sides. Negative 5x equals negative 10. When we divide, x is 2 for our second solution. And then we're going to subtract 1 from both sides, so x equals negative 1. That's our third solution because we had 3 x's there. In number 10, we also have 3 x's, so each of those is going to get set equal to 0. X plus 6 equals 0. X minus 3 equals 0. And x minus 6 equals 0. So we can subtract 6 from both sides, so x equals negative 6. We can add 3 to both sides, so x equals 3. And we can add 6 to both sides, so x equals 6. In number 11, x minus 7 squared. So usually we write that out if we're multiplying, but if we're solving, we just need to do this once. X minus 7 is equal to 0. We add 7 to both sides, so x equals 7. In number 12, there are 3 x terms. So we have 5x equals 0, 4x minus 12 equals 0, and x minus 9 equals 0. In the first one, we're going to divide by 5, so x equals 0. Then we can add 12 to both sides, so 4x equals 12, divide by 4, so x is 3. And for our last solution, we can add 9 to both sides, so x equals 9. So we're going to skip over number 13, and now we're going to work on putting the two ideas together. So when there is an equal sign, this means we need to solve the equation. So first, we are going to do our box factoring, and then we're going to use zero product property. Remember, we only use zero product property if there is already an equal sign and the directions say solve the equation. So in number 1, we have x squared plus 15x plus 0. So we want two numbers that multiply to 50 and add to 15. So two numbers that multiply to 50 and add to 15, they both need to be positive. So we would have 10 and 5. So this factors to x plus 5 and x plus 10. Does not matter which number goes first in which parenthesis. Then we're going to use zero product property. So each of these is going to get equal to 0. X plus 5 equals 0, and x plus 10 equals 0. So in the first one, we subtract 5. X equals negative 5. In the second one, we subtract 10. So x equals negative 10. In number 2, we want to know two numbers that multiply to 6 and add to negative 5. So this time we want a number of two negatives. So two numbers that multiply to 6 are 3 and 2. If we make them both negative, they add to negative 5. So we have x minus 2 and x minus 0. Each parenthesis gets set equal to 0. So x minus 2 equals 0 and x minus 3 equals 0. Then we can add 2 to both sides, so x equals 2. We can add 3 to both sides, so x equals 3. Now, when we're factoring, we need to have it equal to negative 7. So to get it equal to 0, the first thing we're going to do is we're going to add 7 to both sides. So we get x squared minus 8x plus 7 equals 0. Now we can factor. So we need to find two numbers that multiply to 7 and add to negative 8. So the only numbers that we know that multiply to 7 are 1 and 7. In order to get them to add to negative 8, they would both be negative. So we would have x minus 1 times x minus 7 equals 0. And we can take each part and set it equal to 0. So negative 1, x minus 1 equals 0, and x minus 7 equals 0. We can add 1 to both sides, so x equals positive 1. And we can add 7 to both sides, so x equals positive 7. In number 4, we have x squared minus 36 is equal to 0. So we want two numbers that multiply to negative 36, but because there is no middle term, we want to add to 0. So we want the same number. So remember that 36 is a perfect square, so the square root of 36 is 6. So we want to use positive 6 and negative 6. So x minus 6 and x plus 6 equals 0. When we solve, we get x minus 6 equals 0 and x plus 6 equals 0. In the first one, we can add 6 to both sides, so x equals positive 6. And in the second part, we can subtract 6, so x equals negative 6. In number 5, we have x squared minus 30 equals 13x. This is not set equal to 0. So we're going to subtract 13x from both sides. X squared minus 13x minus 30 is equal to 0. So we want two numbers that multiply to negative 30 and add to negative 13. Now, some of us are probably thinking, oh, 3 and 10, and I can make them both negative. The problem with that is negative 3 times negative 10 is positive 30. So we need a different combination. Instead, we're going to use negative 15 and 2. So we have x minus 15 and x plus 2 equals 0. So we get x minus 15 is equal to 0 and x plus 2 is equal to 0. So x equals 15 when we add 15 to both sides. And when we subtract 2 from both sides, x equals negative 2. In number 6, this is already equal to 0. So we are going to multiply to 16 and add to 10. So we want two positive numbers. That's going to be 8 and 2. So we have x plus 8 and x plus 2 equals 0. So each part gets set equal to 0. X plus 8 equals 0. And x plus 2 equals 0. So when we subtract 8, we get x equals negative 8. When we subtract 2, x equals negative 2. In number 7, this is not set equal to 0, so we need to move the 18 over. So we're going to do that by subtracting 18 on both sides. So x squared minus 3x minus 18 equals 0. So we need to multiply to negative 18 and add to negative 3. So we want one of each sign. So we are going to use negative 6 and positive 3. So x minus 6 and x plus 3 equals 0. So each part gets set equal to 0. X minus 6 equals 0. X plus 3 equals 0. We can add 6 on both sides, so x equals 6. And when we subtract 3 on both sides, x equals negative 3. In number 8, we're not equal to 0, so we're going to subtract 24 from both sides. X squared plus 2x minus 24 is equal to 0. So we need two numbers that multiply to negative 24 and add to 2. So again, we're looking for one of each sign, but our bigger number will be positive this time. So we have 6 and negative 4. So x plus 6 and x minus 4 equals 0. Set each part equal to 0. So we get x when we subtract 6 from both sides. X equals negative 6. When we add 4 to both sides, x equals positive 4. Remember then that when we are only going to solve when it's an equal sign. So in the first equation, we would only factor here, but here we would factor and solve.